All right, welcome students. In today's video, we're going to take a look at how to determine if specific values make inequalities or equations true by using substitution. Before we get started, why was the broom late for school? Oh, because it overswept. Get it? Overswept. It's like overslept, but it's a broom. Huh? No? No? Okay, so looking at our first example here, it says 3n equals 24. And for this, we're supposed to determine if the inequalities below are true or false if n equals 4. So we're given the value that n is equal to 4, right? And we are asked to determine if each of these is true or false if n is 4. So what we need to do is just substitute the value 4 for n, evaluate, and then determine if it's correct or not. Okay, so the first thing I'm going to do is I'm going to rewrite this equation. Notice I say equation because it has an equal sign. So equation has an equal sign, right? Inequality, sorry about that, hold on. There we go. So when we talk about an inequality, those are going to be the ones that have like, we see those with these symbols, like the greater than, right? We see those with less than, greater than or equal to, or less than or equal to. So equation, equal sign. Inequality has greater than, less than, greater than or equal to, less than or equal to. And when we say expression, they don't have any of those. They don't have an equal sign or an inequality symbol. So here, again, I'm going to rewrite the equation, but I'm going to substitute n for 4. So I'm just going to replace n with 4. So 3, and then instead of n, I write 4, equals 34. Now we got to be careful. See, when I substituted this in, you see I put it in parentheses. Because when we have a 3 directly next to the n like that, it really means 3 times n. That multiplication is implied. So it's 3 times n is the same thing as saying 3n. So when I substitute that 4 in, it's in parentheses, which means that multiplication is still represented. It is not just putting that n there, 4 there, and making it 34. 3 times 4 is 12. 12 does not equal 34. This symbol with the equal sign with the slash through it means does not equal, so that one would be false. All right, let's take a look at B. We have a fraction here, 24 over n is greater than 6. Remember, a fraction is a division problem. So when we look at this part, right, we have 24 divided by, now instead of n, I'm just going to write 4, is greater than 6. Fraction is a division problem. So this is just 24 divided by 4. 24 divided by 4 is 6. Here's where a lot of people get messed up. They go, hey, 6 and 6, this is true. But this symbol means greater than. So is 6 greater than 6? And the answer is no, because 6 is actually equal to 6. So if the inequality had said 6 is greater than or equal to 6, it would be true. But because it just says greater than, this is false. All right, we got a couple more here, so let's take a look. All right, 14 is greater than or equal to 18 minus n. Again, we know that n is equal to 4. So I'm just going to rewrite the inequality. 14 is greater than or equal to 18. But now instead of n, I'm going to substitute 4 because that's the value I'm given for n. Okay, so now I'm going to do the subtraction here. 18 minus 4 is 14. And the inequality now reads 14 is greater than or equal to 14. Now, because this has the or equal to part, that is a true statement, right? That is greater than or equal to. That equal to part is really, really important because those two do end up being equal. So this is true. So as opposed to the last one for part B, where it said 6 is greater than 6 and that was false because 6 isn't more than 6, for part C it says greater than or equal to. So it says 14 is greater than or equal to 14, which is true. All right, let's take a look at D. So for D, we're given a decimal value, which really doesn't change our process at all. It just changes that, we got to know how to add and subtract with decimals. So 12.5 is greater than or equal to, again, instead of n, I'm going to substitute 4. 4 plus 8.49. Okay, so if I am adding values here that are decimal values, my first step would be to write these vertically and then line up the decimals. So 4 does not have a decimal place on it that's visible. It is implied that it is after. So 4 is the same thing as saying 4.0 or 4.00 in this case because I have 2 decimal places in 8.49. And I'm adding to that 8.49. Making sure you line up those decimals, though, is really important, right? We have to line up the decimal places because otherwise the place values, when we're adding them together, don't have the same value, and therefore our addition algorithm doesn't work. So 0 plus 9 is 9. 0 plus 4 is 4. I bring down the decimal point. 4 plus 8 is 12. So I end up with 12.5 is greater than or equal to 12.49. All right, now, you might be looking at this and going, well, 0.49, that's bigger, right? But actually, 12.5 is the larger value here. And here's why. When I'm comparing 12.5 and 12.49, the 5 is in the tenths place. So if I were to say 5 tenths, that's the same thing. So 12 and 5 tenths is the same thing as saying 12 and 50 1/100ths. And now you can see when I look at my decimal places, when they both have 2 decimal places, you can see the 12 is the same. The whole numbers are the same. So I'm really just comparing the decimal values. 0.50 is greater than 0.49 because 50 is greater than 49. When we're comparing decimal values, we want to make sure we give them the same number of decimal places, makes it easier for us to compare. So this is a true statement because 12.5 is indeed greater than or equal to 12.49. It is greater than. All right. The trick here, take your time, right? Substitute the values in for the variable, test them out, think about what's going on, and then try to figure out if they're true or false. Thank you so much for watching. I hope you guys have a great day. Hopefully this was helpful. Make sure you're doing the try this on the bottom and the back, and then the review on the back.